Okay, A2, not that good. Okay, let's see. When you get it, once you get it back, then we'll look at where you have gone wrong. Okay. Well, are you happy with your A2?
No.
Okay. So we should be looking at this one. Okay, good. So okay, before we talk about binomial expansion, which is by the way, this is the formula for you to expand 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 an expression of any power. Okay, so I don't think you have problems expanding this to the power of 2, right?
Yeah.
So this is, I think you can remember that formula. So it's the a minus b bracket to the power of 2, right?
Yeah.
So what do you get?
A square minus 2ab plus b squared.
Okay, good. So yeah, so this is the formula to expand this one, right? So you will get x squared minus 2x plus 1. All right? Yeah. And for this one, I think you can also use you can use this way. So
Yeah, and then
break it up.
square.
Yep, split it. Nice. So you split it. So once you split this to this format, then you will do the square. You will do the square here first using using this one, right?
Yeah.
Okay. So I'm not going to elaborate here. Okay, just dot dot dot, right? And after that, you just open the brackets further, right? And then I think to the power of 3. Okay, this is under the topic of polynomial, right? Polynomial, right? And then so in fact I think these two, okay, these two they are covered in the polynomial chapter, right? And then now we what can we do, or there is a way for us to expand an expression of any power. Okay, so beyond 4, beyond 5. Okay, so what about if you get this? So how do you expand this? Okay, so let's learn the basic stuff first. So what do you see here? Okay, what do you see here is, okay, over here, okay, this way of expressing the answer is in descending power.
Yes.
Okay, descending power. All right, so now if this way is in descending power, right, then okay, okay, that's this is the first observation. Okay, the second observation is, what is your second observation? If you have to the power of 2, right, you are going to have, so if it's something to the power of 2, you are going to have 3 terms generally. All right, so you have the, so without opening the brackets, I think you can see that you will get the x to the power of 2 term, right? If something square, you will get the x to the power of 2 term, or something to the power of 2 term, and then x to the power of 1 term, and then x to the power of 0 term, which is this is called the x to the power of 0 term, which is 1, right?
Yes.
Right? Or another way, this term is called the independent of x term. Independent of x term. Can you see? Independent of x. Independent of x means nothing to do with x.
Okay.
Okay? Can you see over here is x to the power of 2, x to the power of 1. So you still have the x, right? Okay? And then whatever in front is called the coefficient, right?
Yes.
Yeah. So the coefficient of x to the power of 2, coefficient of, okay, just coefficient. This is the coefficient. And then for this is called the independent of x. Independent of x means no x. Okay? Or you can call this the constant term. What's the meaning of constant? Stay the same, right? So if this is 2, it's 2 throughout. No change.
Yeah.
Okay? So yeah, so these are the observations for this expression to the power of 2. Okay? So now if you look at this, you have this bracket 3x minus 1 to the power of 6, right? So without using the formula, I think you can have a few conclusions, right? So you are going to have 7 terms. Why? Because it's power 6, right? So you're going to have like something x to the power of 6, 5, 4, until x to the power of 0, right?
Yes.
Okay, and then of course in between you might not have the x to the power of 5 term because the coefficient is 0. But when you don't have that, doesn't mean it's not there. It's there, but the coefficient is 0. So that's why you don't have that. But generally, without expanding this, you should have this in mind. If I expand this, I'm going to have this, and then okay, six,
Okay.
seven terms. If you have power 6, 7 terms. Okay, and then of course your job is to figure out these 7 terms.
Oh,
Right?
okay.
Then you have to make use of the formula. Okay, so let me use the formula to illustrate this to you. All right. So this observation is you should have this conclusion first. So next is in this case your 3x is your A, right? Can you see? And then minus 1 is your B, right? Okay. And then your
Okay.
power is the n is 6 here.
Yes.
Okay. So yeah, so you just put everything into the formula.
Oh.
So you have your an, right? So an is your 3x to the power of n, right?
6.
6 in this case. Yeah, thank you. Then the next one is
6.
6, choose 1. Over here it's called choose 1. 6, choose 1. So later I'm going to teach you how you can use the calculator to get the result for 6, choose 1. 6, choose 1. Okay? Okay. You can use calculator to figure it out, or you can use the formula here to figure it out. Okay, but let's not worry about that first. Then now is what? Now is a again. So it's 3x to the power of n minus 1, right? So n minus 1 is 6 minus 1, so it's 5, right? And then b is, okay, b is what? Minus 1. Minus 1 in this case, right? Okay. Then subsequently you have 6 to power 6 2. I'm here already.
Yeah.
So you have the a n to the power n minus 2, right? So it's 4 here, and this is 3x, and then this is minus 1, so you have the 2 here, can you see? Then dot, right?
Yeah.
Okay, so you just complete the rest. Okay, so I don't think this is a very good way for you to, okay, of course, every single time this formula is given during your test or exams. Okay, this formula is always given.
Oh.
Okay, but I don't think it's I have a way for you to so-called I'm not saying it's easier, but it's actually easier. Okay, so given given any expression you can actually do this. So let's say you have 2x plus 1. Okay, let me make it easier to illustrate the point. So let's say you have to the power of 6. Okay, so instead of using the formula, which you can always refer to, but I don't prefer that. But what I know is, so from this example, right, I know it's going to be like x to the power of 2 first, and then descending power, right, until the x to the power of 0, which is the independent of x term, right? So similarly, so you always start with 3 brackets. I'm going to explain to you why later. Okay, so you are going to have how many terms? Power of 6. You're going to have 7. So you're going to have, okay, let me make it easier. Let me not play with 6 first, because I don't have enough space. Let's to the power of 4. So you're going to have how many terms? 5 terms, right?
Yes.
Whether in between you get a 0 coefficient that erases the one of the term, we don't care about that at the moment. But we know that, okay, we should have 5 terms. Okay, if there is a 0 coefficient in between, it will take care of itself later on. Okay, but we don't do that judgment first. Okay, 5 terms, and then yeah, supposed to have. Okay, so since I don't have enough space, so I only have 1, 2, 3, 4. So I will just reduce the power to fit my this space, which you can't do. Okay, so if they give you 5, so you just need to plan your space. Okay, so if you have power 3, you only have 4 terms, right? You have 4 terms, and then this is the first. This is going to give you the, so this is going to give you the first term, the second term, the third one, and the fourth. So far so good. Yeah, so what you fill up into all this, okay, pretty simple. This will be your A, this will be your B. So your B in this case is your plus 1. Plus 1, I write it as 1. This will be your A, this will be your B, this will be A, this will be B, A, and then B. Okay?
Okay.
That's the first thing you write. Then the next one is, so like I say, right, if it's power 3, 4 terms, so that gives me first, second, third, and fourth, right? The second thing you observe is the highest power is always the first one, right? Right?
Yeah.
Based on the simple example. So meaning what? So what's the highest power for this? It's 3, right?
3.
Then over here is 2, 1, 0. Okay? Does it make sense now?
Yeah.
Okay, good. And then in the formula, you always have the highest power choose something. So highest power choose something, highest power choose something. So the highest power is 3 in this case. Okay, so if you refer to the formula, it's always n. Can you see n choose something?
Yeah.
Okay, over here you don't have the n choose something. Actually you have. Actually it's n choose 0.
Oh.
Okay, so never mind. I don't want you to memorize, but so far I want you to realize is, if you have if power 3 is 4 terms, and then you write down this four groups of brackets, and then the next thing you fill up is the A. Okay, and then the next one you fill up is the B. Alright, and then the next step is you fill up with the, you don't fill up with these 3 first. You fill up this 3, 2, 1, 0. Why? Because you know that if you have something to the power of 2 is x to the power of 2 for the first term. Yeah. So therefore you manage to write the 3 here. 2 next, 1 here, 0 at the end. Okay? We don't do any calculation first. We fill it up first. So next is fill up the 3 above. So 3 above, 3 above, 3 above. So this will be your 3 to the power 0. 3 choose 0. 3 choose 1, 3 choose 2, and 3 choose 0. Okay?
0.
Yeah. Oh no. Okay. 0, 1, 2. Okay, it's 3.
Yeah. So that answers.
Yeah. Good. So that means if you make mistake, you have to be able to self-correct. Okay. So therefore, the last thing you fill up is this. What's the power for the 1? And how do you get the power for the 1? Pretty easy. 3 minus 0. So can you see 3 choose 0 here?
Yeah.
Yeah. So the 0 is here. Okay? So the 1 is here. The 2 is here. The 3 here. The 3 is here. Okay, another way to look at this is 3 plus 0 must add up to 3. 2 plus 1 must add up to 3. So 1 plus 2 must add up to 3. 0 plus 3 must add up to 3. Meaning what? Meaning these 2 let's say you choose, okay, I don't think you have problems filling up this one, because it's always 3, 2, 1, 0 if the power is 3 here, right?
Yeah.
So once you get the 3 here, right, and once the 3 is above here, you can only fill up 0 here. You know why? Because these two power add up must equal to this. Okay? As you do more often, you will realize. So let's just take it as it is first. Let's take it as it is now. So, yep, done. So now your job is to use your calculator Can you take out your calculator? Then figure out what you cannot figure out mentally. So 3 choose 0 is the you should find out this button. So I think it's PCR. Can you see here? Shift the divide, N choose R. Can you see that? So so what you do first? You key in the 3 first. You key in 3, then you shift the divide button. Then you put 0.
Like this?
Can you see? Yes. This is called 3 choose 0. So what do you get? 1. Okay, good. So you get 1. And then x to the power of 3. Okay, x to the power of 3. 1 to the power of 0. 1, right?
Yes.
Okay, next. 3 choose 1.
3.
Okay, 3. So x to the power of 2. 1 to the power of 1. Okay. 1 to the power of 1 is 1, right? 3 choose 2.
3.
Okay. Then x to the power of 1. Then 1 to the power of 2 is 1. Okay. Good. Next. 3 choose 3.
1.
Then x to the power of 0 is 1.
It's just
okay.
1.
So therefore you simplify it and tidy it up a bit. So this is the expansion for the x plus 1 bracket to power 3. Okay.
How does this choose work? How do you like calculate the
Yeah,
choose?
that's manually, right? So you're talking about manually,
Yeah,
right? So okay, let's not talk about that first. Okay. I want to let you familiarize with the format. Okay. The format. How do you fill up the brackets? Okay. So good. Next. So let's pick one example. So the formulas are all here. Like you asked me how you use the formula, right? To manually figure out something, choose something, right? So these are the formulas. Okay, you can work out manually using the formulas here. I'm not sure it's given. I think it's given. So let's take a look at this question. So it's okay. Never mind. Let me just get the other one. No, I don't want this. So over here, they want the independent of x term, right? Can you see they want the x independent term?
So it's like the constant. Must find the constant.
Yeah, find the x to the power of 0. Yeah, or the constant, right?
Yeah.
Okay, good. So independent of x. So you just write down x to the power of 0. Okay, so over here is to the power of 12, right? So meaning what? You're going to have 13 terms. Right?
Yeah.
Yeah. Then that means, so okay, so the structure is, so once again the structure is equal. So I don't write the answer. I mean I don't write this again. So I assume that you know that. So this is the first, the second, then of course third. Okay, then subsequently until the 13th one, right? So it does not make sense, right? So it does not make sense to do all, right?
Yeah, since they already say independent, can't you just like write down the last group of brackets?
So in fact, right? In fact, you are not supposed to write down all of them because it's stupid. You waste your time.
Yeah.
Okay, so it's waste time. So that means it requires some smart calculation and smart decision making to pick out the x to the power of 0 term. Okay. Okay, but never mind. I want you to practice the first 3. Okay, because the structure of this is important. Okay, so we are talking about this 12, right?
Yes.
Meaning what? Meaning we are supposed to have the something 12 at first. So that means I should fill up the a and b first. So this is x to the power of 2 here. 1 over x to the power of 2, 1 over x to the power of 2, 1 over x. So far so good? Okay, so since this is the first term, right, the power has to be 12 here.
Yes.
And then 12 should be here. Oh, that means let's okay, let's say you don't fill up the power 12 first. Just write down the 12 truths first. Because it's always 12 choose something throughout. Then for the first one is always 0, and then this is 1, this is 2, and then of course subsequently, right? Then now it becomes very simple. 12 minus 0 is 12 here. Therefore you have 12 minus 1 is 11 here. 12 minus 2 is 10 here.
10.
Okay, good. So subsequent, right? And then what are you going to have here? 0, 1, 2. Okay? Let's say you make a mistake. Let's say you put a 3 here. Impossible. You know why? Because this is 10, this is 3. You're going to have 13 if you add them up. The highest power here is 12 for the expression. So you cannot have 13. So it's 2.
Oh.
Are you clear?
So whenever both of those powers add up, is always 12.
Yes. Meaning these 2.
Yeah, meaning that
Yeah.
those things.
Okay? It's always 12. Okay? Good. So yeah. So now let's look at the first 3 terms first. So sometimes they say, oh, I want the first 3 terms. Please give me the first 3 terms. So let's get the first 3 terms. I'm not answering the question at the moment. I'm just letting you get a feel of how you can use the. I'm not asking you to memorize the formula also. I'm giving you a kind of like a shortcut, without requiring you to memorize the formula, because I think the formula looks a bit daunting to you, right? Scary, right? Right? Okay, good. So can you help me out with your calculator? 12 choose 0. Yeah? I think it's 1.
Yeah. Remember, something choose 0 is 1.
Yeah, I mean, yeah, you can always depend on your calculator, but you can't depend on your brain. Okay, I don't depend on my mental calculation, so I let the calculator give me the answer. So over here you have x to the power 24, because 2 times 12, right?
Oh.
Then over here you have anything to the power of 0 is 1. Okay, can you give me 12 choose 1?
12.
Oh, okay, good. So this is 12 to x to the power 22. Then over here you have 1 over x. 12 choose 2.
66.
66.
Yes.
Okay, good. So this is x to the power 20, and then this will be x to the power 2 below. Okay, because the 2 will go here,
And bottom.
and then
So the top one is always 1.
Yeah.
Okay.
Okay, so I don't try to memorize the top one or the below one. I just do the normal calculation. Okay, good. So then you plus dot, right? Okay, good. Then the first one you will get x to the power of 24. Then the next is going to be 12. So this one cancel with this is x to the power 21. So it's x to the power 21. Then you have the 66. Then so this cancel with this is x to the power of 18, right? Then it's dot. Do you know how I get 18 for the power? Because you just do this one. So delete 1x. Okay, so you get x to the power 21, right? So over here you get rid of 2x, so you get, x to the power 18, right? Okay, good. So this is the first 3 terms. Okay, but anyway, you look at this. Hey, I don't get the x to the power 0 term, right? Then that means the answer is, how do you get the x to the power 0 term, right? So okay, why you cannot assume that, hey, x to the power 0 term easy, right? I just go to the end. That means the last term.
Yeah.
But one thing you need to realize here is the interaction between these two. Because the interaction of, can you see the interaction of these two or not? Okay, just now I show you how you get your x to the power 21, right? It's x to the power 22 over x to the power 1, right? So that means and this x to the power 22 is from where? Okay, so actually I want you to realize that the interaction between this term and this term, this term and this term, will give you the x to the power 0. Okay, there is this interaction between these two terms. It's not that, oh, I get x to the power of 0 here, then okay, good enough. No, depends on the next one, whether it will help you. That means the interaction between the a and b will give you the x to the power of 0. Okay. Okay. So the question you ask yourself is, hey, what power? So I know I need to get the x to the power of 0 term independent of x. So that means you need to ask yourself, it's always 12 here, okay? 12 through something. And this is your a, right? And then this is your b. It's times in between. So that means the question you ask yourself, what I put here and here, and these two will give me x to the power of 0 term. And these two, so let's say if this is x, this is y, right? So meaning what? Meaning your x plus y must be 12. Okay? And basically you are solving simultaneous equations now. And this is going to be your x to the power of 2x, right? This one. And then this is going to give you your 1 to the power of y is 1. So this is 1. So x to the power of y. And this will give you the x to the power of 0. So basically you need to solve this 1 and 2. Then you will figure out what's the x there, what's the y there.
So you cannot.
And probably I shouldn't use x and y because the x is taken already. So I use a and b lah, because I cannot use x, x is here. So it's going to have a double x. I don't want to have double x. Are you clear?
Okay. So you cannot put like 0 and 12. Because
You put 0 and 12, you can test. It doesn't work. That's why I suggest you to use these simultaneous equations. So this is 1. 1 to the power anything is 1. So this is your b. So yeah, good, done. So how do you solve this simultaneous equation?
x to the power of 0 is 1.
So no, don't look at it that way first. So you just do a bit of so basically do something to this first. So your x to the power of 2a. So I'm going to do it here. So x to the power of 2a over my x to the power of b is equal to x to the power of 0, right? So for this is x 2a minus b equals to x to the power of 0. So therefore 2a minus b is equals to 0. Okay, good. So what I'm using here is, let's say if you have your a to the power of 3 over a to the power of 1, you will get a to the power of 3 minus 1, which is a to the power of 2. You can verify that yourself, because you have 3a above, you have 1a below, you will end up with 2a, right? Yeah. So that's why I make use of this concept. Okay. So over here same thing. You have 2a above, b. So the power you use minus. So once you have this x to the power of this, x to the power of 0, then you can actually get rid of the x. So you will end up with 2a minus b equals to 0. By comparison, this is another by comparison method.
Yeah.
Okay. So done. I think you can solve this, right?
Yeah.
Can you use your calculator quickly and give me the answer? Or maybe no need to give me the answer, I already figured it out. A is 4. Then if a is 4, b is equal to 8. How I get a equals to 4?
Yeah.
Solve this simultaneous equation.
Oh.
Yeah. So 1 plus 2. 1 plus 2 give you 3a. These two cancel each other. So 12. A equals to 4, right? Yeah. So a equals to 4, so your b must be 8, right? Right? So therefore, you can fill up 4 here. And then 8 here. And then this one must be 4. Oh, no, 8. Why must be 8? Not 4? Okay. Like I say, 4 plus 8 must equal to 12, right?
Yes.
Okay. Then your this 4, right, and this 12, right, this must be 8.
Oh.
Okay. So 12 minus 8 is equal to 4. or
Okay.
yeah, yes.
Okay.
Okay, can. Okay, good. So therefore, yeah, this is the term. So if this is the term, yeah, let me show it. So can you help me out? 12 choose 8.
495.
495. And then this will be x to the power 8, right? Then this will be 1 over x to the power 8. So can you see? It's 495. This one cancel each other, right?
Yes. So.
So, yeah,
0.
it's 495.
Yeah.
Okay, so the answer is 495.
Okay.
Okay? Okay? Okay?
Mm.
Good. And by the way, if let's say you don't use the simultaneous equations to solve this, so you can play with it. Meaning what? If you put a 2 here, here will be 10. Because these two power must add up to 12, right?
Yes.
And then this is 2, so the below here must be 10. But anyway, you will know that, oh, this is x to the power 4, this is x to the power 10, x to the power 10. Below, you will get the x to the power negative 6 term in this case, which is not what you want.
Okay.
Okay? Okay? So, yeah. So, going forward, they will not ask you to expand the entire thing. They just want that particular term. Then you have to make use of the, I will say this is called the, if you cannot do smart guess, like a smartwatch or a smartphone, then you have to use the simultaneous equations
Okay.
method.
So anytime they ask you, you cannot assume. You must use the simultaneous.
If you don't, then you have to guess and check.
Okay.
Yeah, guess and check. Right?
Yeah.
Yeah. Okay. But with the simultaneous equation, it's much faster, right? Good. So over here, they want the x to the power 4 term. Okay. So once again, okay, write the 3 brackets down. This will be 12. This will be your A. This will be your
B.
B, right? So how do you get the x to the power 4 term?
Isn't it 2?
So if you put a 2 here, then this will be 10, right?
Yeah.
Then here you will get x to the power 4. Then this you will get x to the power 10. This will be the x to the power minus 6. So cannot. So you can say 2 and 10 doesn't work, right?
Yeah.
So this is called what? This is called uh, guess and check, trial and error. You're going to spend a lot of time if you can't. But after you have done enough, right? After you have done enough, I think you probably can somehow find the can really guess smartly and fast.
Okay.
Okay. So try what?
Um,
Oh, is there an x to the power 4 term? Okay, 5 and 7 is pretty close. 5 and 7 is x to the power 10, and then x to the power 7, so it's x to the power 3, right? Yeah. So 5 and 7, pretty close. So cannot. So it's 6 and 6. So 5 and 7. So what about 4 and 8? This is 8, 8. Cannot. Okay, 8 and 8 is the x to the power 0, 0. So just now we test already. Just now 4 and 8 we will get x to the power 0 term, right?
yes.
And then we test the 5 and 7, we will get the x to the power 3 term. So that means the next one we test is 6 and 6, right? So you are going to get your x to the power 12 and then this x to the power 6. So you don't have the x to the power 4 term. Okay?
So don't
Okay?
have.
Don't have.
So this one you just made yourself.
Yeah.
Oh.
So therefore the don't have, right? You
Yeah.
you check already. So I put the 4 8, I get x to the power 0. I put 5 7, I get x to the power 3. I put 6 and 6, I get x to the power 6. Can you see?
Yeah. You just skip.
Yeah. It skip, right?
Yes.
So therefore there is no.
Wait. So do we have to show like we?
Oh, so by the way, how you show this? You can show the I will say you show the x to the power 3 term. and then you show the x to the power of 6 term, and then you say, okay, you just jump. You just
Okay.
skip the x to the power 4 and x to the power 5 term.
Okay.
Okay? Alright? Okay, good. Okay, good. So over here, right, they expect you to expand everything. Okay? So yes, this question they want you to expand everything. So pretty easy. So this is power 6, right? So how many terms you are going to have? 7 terms. Right?
Yes.
So 7 terms, 7 groups of brackets. Second group, third group, fourth, fifth, sixth, 7. Now your job is to fill up. So this is 1p, 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 1p. I would say it's very mechanical. Okay? No knowledge required, no intelligence required. So like you say, okay, in this case, right, we talk about x plus 1 to the power of 2 is x to the power of 2 first, right? Descending order, right? Why? Because we put the x first. That's why you have the x to the power of 2 first. If you have the 1 plus x, if you put it in this manner, you are going to have ascending order, because you open up the 1 first. Okay? So in this case, your 6 is going to be here for the 1. Okay? So if 6 is for the 1, so it's 5 here, 4 here, 3 here, 2 here, 1 here, and 0 here. Right? So therefore, if 6 is here, here has to be 0, because they need to add to the 6. Okay? So it's 1. So 0, 1, 2, 3, 4, 5, 6.
Why your 1 is in there? Voided.
Yeah. So nothing here. Okay. Then 6 choose 0. Because 6 minus 0 is 6, right?
Yeah.
Okay, so this is 6 choose 1. Oh, my 1 is here, sorry. So this is 6 choose 2, 6 choose 3, 6 choose 2, 4. In fact, it's pretty easy. 0, 1, 2, 3, 4. So it's 6 choose 5, 6 choose 6. So therefore, can you help me out? I think 6 choose 0 is 1, right?
Yes.
Yeah. Okay, so the first one is all 1. 6 choose 1, I think is 6.
Yes. Yes.
Okay, good. So it's times 1 times p. 6 choose 2?
15.
Times 1 times p to the power 2. 6 choose 3?
20.
Times 1 p to the power 3. 6 choose 4?
15.
1, 5, and then times 1 p to the power 4. 6 choose 5?
No, it's p to the power of
4. Right?
No, the third one is.
This is p to the power 3, right?
Oh, okay. Never mind.
Okay, good. So 6 to the power 5.
6.
6 choose 5, I'm sorry.
Yeah,
6. Okay, good. P to the power 5. 6 choose 6? 1. Okay, good. 1 and then p to the power 6. Okay, good. So simplify 1 plus 6p, 15p square, 20p cube, 15p4, 6p5, and then p6. Okay, good. So done. They want extending powers. Why you get extending power? Because your 1 is actually your a. When you open up, you open the 1 first. Okay? Yeah, just this example can illustrate to you. So whenever you have doubts, right, always give yourself a simple example, so that simple example can illustrate. Okay? The can actually give you some wisdom. Okay? What is going to happen for your this more complicated question. So hence find the first 3 terms of this expression. So how is these two related? Okay? They are related in the sense that, can you see that your 1 is here? and then your p is this, so your p is this. Okay. Okay. So if they want the first three terms, right? Meaning what? Meaning?
The first three.
So the p will be replaced by 2x plus 2x squared.
Yes.
Right? Right? So therefore, the first three terms means deng, deng, deng. The rest, no need.
Yes.
Okay? Because they want first three terms, right?
Yeah.
So, okay, so
Substitute.
so you just first three terms. Just write down first three terms of this one equal 1 plus 6. So this is 2x plus
2x squared. Then 15 times 2x.
15, yeah, 15. 2x plus 2x squared to the power of square, right?
Yeah.
Okay. So the first three terms of this, yeah. Okay. So yeah, that's it. So you just solve this. So you get 12x.
Plus 12x squared.
Yes.
Then 15.
Well, no, not yet. Must open this
Yeah.
square
15
first.
times 4x
Yeah.
squared.
Very good. Hold on. 4x squared plus
4x cubed. Sorry.
8x cubed plus 4x 4, right? 2 power 4.
Yes.
Yeah. Okay. So this is just expansion, By the way, I'm using mental calculation, So
Yeah,
I might make mistake. So don't trust your mental calculation. Just use calculator. But anyway, I try to speed up a little bit, so it's okay. But the answer is not so important. The more important part is the approach and the concept. Yeah. Okay. Good. So this is the first. Oh, this is not the first three terms. In fact, this is the first. How many terms? 1, 2, 3, 4, 5. So you don't have to give 5.
Oh.
So the first three terms should be this. So what I'm trying to say is this. So instead of hold on, So before you write the first three terms, you just write this and then you write this and then with plus dot 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 plus dot 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 plus dot dot dot, and then you just pick the first three terms.
Oh.
You understand me?
Wait, what does the question say?
First three terms. The first three terms of this, right? Then I realized the first three terms is actually these three. That is the fourth, that is the fifth, right?
Yes.
You understand me? You understand me or not? So in fact, if you do more, it's fine, because if you do more, you ultimately you just pick the first three, right? You get me? So if the question asks for first three, you don't go and give first 5. You don't give more. All right? So you see, I just realized I have more than required, so I just shorten it. Okay, I use dot dot dot. So you just answer the first three terms. Okay, the first three terms are 1 plus 12x plus 72x squared. Alright?
Okay.
Simple? Yeah, pretty simple. And then it says use your result to find the value of this. Okay, good. So in fact, this is also quite simple. If you can tell,
this equals to 1 plus
1 plus 2 times
2x.
10 to power what?
Huh?
This is equal to what? This is 2 times 10 to power negative 3, right? Yeah. And then this is 2, then this portion is 10 to power negative 6, if I'm not wrong. Can you help me out? Use your calculator. 1 plus 2 times 10 to power negative 3 plus 2 times 10 to power negative 6. Do you get back the 1.002002? Hold on, hold on. Yeah,
Yeah.
yeah, you get back that? So meaning what? Meaning they want you to see this, right? This thing, right? They want you to see this thing as this. Or rather, they want you to see this. I have done a bit of hold on, this is your x. They want to see this.
Let me just. Oh, okay.
Alright?
But here it doesn't give the same answer. Oh, it's after you. Okay.
No to the power of 6. No to the power of 6. Yeah. That means without the power of 6 first. Without the power of 6 is the 1.002002.
Yeah.
Okay? So they want you to see this in this format. So once you see this in this format, right, then you by comparison you can see what? This is your P. Your P now is what? 10 to the power negative. Or your X is your X here.
Oh.
Can you see that? So your P is actually not P, your X, sorry.
X is 2. Wait, sorry.
X is the 10 to the power negative 3. Yeah. Okay?
Okay.
So if X is 10 to the power negative 3, so if X is 10 to the power negative 3, you just put it in.
1 plus 12.
But if you cannot see, then you don't get these marks.
Oh, yeah.
Then, yeah. Then you get the answer. Okay? Yeah. So basically the last part, right? The last part is you somehow, right, you get this, right? You need to see in this format. Like in this format. So, it's this. Okay? Okay?
Okay.
Okay? But anyway, I want you to focus on this, like the expansion. And the any term they want. Sometimes if they ask you for the x to the power 4 term, you don't have that. Remember that question? They ask for it, but you don't have that.
Don't have.
Yeah. Okay, good. So we can actually take a look at the manual way of doing it. Okay, so n choose 0 is 1 huh?
Yeah.
Yeah, so no need to argue against it. Okay, so this is the general formula. Okay,
Okay.
so you want n choose 5. Let's do n choose 5. So n choose 5. So n choose 5, if you look at this, right, is no, I need to have numbers. I cannot use n, 10. Okay, let's choose 7 huh? So 7 choose 5, according to this formula, is 7 factorial. This is called factorial. Factorial.
Exclamation mark.
Yep, so in mathematics it's called factorial. So I will point to you how you get this.
It's
But-
7
but-
times 6 times
5.
5.
Yeah, until times 1.
1.
Okay, good. But you don't want to use, okay, maybe, yeah, just, okay. So next is, can you see the r factorial? So it's 5 factorial.
5.
And then what is? So it's 7 minus 5, so it's 2, in this case 7 minus 5 factorial. So you can use your calculator, right? Actually you don't need, let me show you.
You just
Yeah,
7.
so this is 7 factorial, right? So 7 factorial, if you expand it like you say is what? Is 7 times 6 times 5 times 4 times 3 times 2 times 1.
Yeah.
So 5 factorial is 5 times 4 times 3 times 2 times 1, right?
Or you can just take away the 4.
Yeah,
times
exactly. Yeah. So over here is 2 factorial. 2 factorial is what? 2 times 1, right? So can you see that you can take away this chunk?
Oh.
You can delete both the top and bottom.
So it's just 7
So
times
7
6.
times 6 is 42 over 2. So this is 21. Can you like verify? Is it 21? 7 choose 5.
Yeah.
Yeah. Okay. So I have demonstrated to you how you can do it without calculator. So if they ask you to do it without calculator, you have to demonstrate that you are using this. Okay, you are using this manual method.
Okay.
Okay, you cannot. I think you can cheat a bit by using the calculator to verify the answer. But you cannot say, hey, 7 choose 1, then give 2. I don't know what is 7 choose 1, because I need to times all this together. I don't think I have the brain power to do this.
Yeah.
Okay, I think I can, but not fast. So I give up. All right, but you don't need to expand it. I mean, you don't need to get this multiplication result, right? Because you cancel with the below, right?
Yes.
Yeah. Okay. So the answer is 21. All right.
Oh.
So so if you don't get the numbers, if you get the n, right? If you get the n, right, then you have some useful rules. So you can actually yeah, if you get an n, then you will get this. Okay. Okay. Yeah. Good. Okay. So okay, good. That is the first half of our lesson. Okay.